This lesson is Lesson 8, Polynomials. Previous lessons we've talked about specific types of polynomials like monomials where a single term, or quadratics where we have three terms, a trinomial, but this is just going to be a general discussion of polynomials in general and how to deal with them. Let's start by talking about the definition of a general polynomial. A polynomial is a single term or multiple terms containing variables with whole number exponents. So let's start by talking about the degree of a polynomial. So let's start by saying if we had a very simple polynomial, ax to the n, the degree of the polynomial would simply be the exponent n. So in this case, the degree is n. Or if I had something like 7x to the third, the degree in this case would again be 3. Okay? So that's the degree of a polynomial. So let's further define a polynomial by finding out what the definition of a polynomial in X is. So the result is this rather complicated expression here of a sub n x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2 all the way down to a to the 1 x plus a sub 0. Now in this case, the coefficient a are real numbers. So all the a sub n minus 1, a sub n minus 2, all the way down to a sub 0. Those are all real numbers. And n is a non-negative integer. The degree of this polynomial is n, and a sub n is the leading coefficient, and a sub 0 is the constant term. So let me repeat. The degree of this polynomial is n, and a sub n is the leading coefficient, and a sub 0 is the constant term. So now let's look at the case where we have the product of two binomials, okay? And one of the methods we can use with this is FOILing. So let's look at this example. Here we've got 3x plus 2 times 4x plus 5. If we were to do traditional FOILing, first, outside, inside, last, the result would look something like this. 3x times 4x plus 3x times 5 plus 2 times 4x plus 2 times 5. Now you could also use the method we used in a previous example where we had a binomial multiplied times a trinomial. That would look like this. 3x times 4x plus 5 plus 2 times 4x plus 5. In either case, however, you're going to get the same answer. And that answer is 12x squared plus 15x plus 8x plus 10. Now all the examples of polynomials that we've used so far have been in one variable, but that doesn't mean we couldn't have several variables in a polynomial. We could have a polynomial that looks just like this: 7x squared y cubed minus 17x to the fourth y squared plus xy minus 6y squared plus 9. So this would be a perfectly acceptable polynomial in two variables. Now, in this particular case, the degree of this polynomial would be the highest degree of all its terms. For this one, it would be 6, because 4 plus 2, 2 plus 3, so the degree of this polynomial would be 6. As far as adding, subtracting, and multiplying polynomials with multiple variables, the rules will be the same as what we've talked about with a single variable. Adding and subtracting, you would add and subtract like terms. Multiplying, you would just follow the rules of multiplication and then combine like terms. Now this concludes this particular lesson. Now proceed to the worksheet and see whether you understand the material that has been presented. And don't forget, if you have questions, take and enter them in the discussion portion of the lesson, and I will respond and answer them as quickly as I can.